Today we are going to start a new chapter of the 10th standard, that is refraction of light at plane surfaces. So from our 8th standard we are very well known about reflection. We know about the phenomenon of light, that is reflection. What is meant by reflection? So when the light is incident on any object, it will reflect into the same medium. It will reflect into the same medium. The light will bounces into the same medium. That phenomenon is nothing but reflection. So because of the reflection only, we are able to view the objects with our eyes. For example, if I was able to watch this object, what was happening there? The light is incident on this object and that light will bounces back into the same medium. Here the light enters from the air and bounces back into the air only. So because of the bouncing back light, we are able to view this object. We are able to visualize the object. So here the ability of visualizing is occurred due to the phenomenon of reflection. What is meant by reflection? When light incident on any object, it bounces back into the same medium. That is reflection. So here now we are dealing with a new phenomenon of light, that is refraction. So what is how this refraction of light will occur? How we will encounter the situation of refraction in our daily life? So let us consider a glass beaker. Let us consider a glass beaker filled with some water. So I have considered a glass beaker with some water. So if you place a stick or a pencil inside this glass beaker, if you place a stick or a pencil inside this glass beaker, you will observe this is the actual shape of the stick. This is the actual shape of the pencil. It will be in a straight line. The structure of the pencil is straight. But if you are observing the structure of this pencil, you will observe a small bend in its structure. You will observe a small bend in its structure. So what is the reason behind it? How can you explain this phenomenon? How can you explain this optical illusion? It will appear as a small bend in its structure. So what is the reason behind it? Or sometimes the lemon placed inside a glass containing water. We have placed a lemon inside a glass containing water. So here the size of the lemon appears larger than its actual size. How can you explain this one? So these are the questions arise from our daily life. So what is the reason behind these two phenomena? How can we explain this? So these can be explained with the phenomenon of refraction. These daily life examples can be explained with the phenomenon of refraction. So now let us know what is meant by refraction. Refraction. So when light travels from one medium to another medium, so let us consider two mediums, that is I have considered here air and another medium as water. I have considered two mediums, one is air and another one is water. So this is the boundary that separating the two mediums, air and water. It is the boundary that separates the two medium, air and water. This is the surface of the water. So if you incident light on the boundary of the two mediums, this is the actual path that has to be taken by the light. But the light will bend and travels in further direction. The light will bends and travels in the further direction. So this phenomenon is called as refraction. This phenomenon is called as refraction. So what is the meaning of refraction? When light travels from one medium to another medium, when light travels from one medium to another medium, it will bend. So the refraction is defined as the bending of light when it travels from one medium to another medium. This phenomenon is called as refraction. So refraction is nothing but the bending of light The bending of light when it travels from one medium to another medium. When it travels from one medium to another medium. Here the direction of the light is changing. The direction of the light is changing. It is changing its direction. It is changing its direction. So, in order to measure the directions, in order to measure the change in direction of the light, we need to deal with angles. So here we will observe there is a change in the direction of light. So in order to measure those changes in the direction of light, we need to deal with angles. So that the light incident on the boundary of the two surfaces is called as incident light ray. This incident light ray. This is the incident ray, and this ray is called as refracted ray. When light is traveling from one medium to another medium, it will bend and travels in the forward direction. The bent light is called as refracted ray. Refracted ray. So in order to measure the angles, you need to draw the normal at the point of incidence. So the light is incident at this point, and this point is called as point of incidence. So in order to deal with the angles, you need to draw a normal line. What is a normal line? The line which is drawn perpendicular to the boundary of the surface is called as a normal line. So I have drawn a normal line. So here this is a normal line is represented as N. So the angle between incident ray and normal line is called as incident angle. The angle between incident ray and normal line is defined as incident angle, and the angle between normal line and the refracted ray is called as refracted angle. The angle between incident ray and normal line is called as incident angle, and it is denoted with I, and the angle between the normal line and the refracted ray is called as refracted angle, and it is denoted with R. So let us see how the refractions will be observed when it is traveling from one medium to another medium. There are two cases. So consider the first case, case 1. When the light travels from denser to rarer medium. When the light travels from denser to rarer medium. How the light will bend when it is traveling from denser to rarer medium. So I have considered two mediums. One is water and another one is air. So since water is having high density, it can be called as denser medium, and when compared with the water, air density is very less, and hence it is a rarer medium. Denser means high density medium, rarer means low density medium. So here, this is the boundary that separating the two mediums. So here the first case is when the light is traveling from denser to rarer medium. So I have considering the light coming from the water. So I have considered a light ray. So in order to deal with the angles, I will draw a normal line. Here. So this is the normal line at the point of incidence. So this is the actual path of the light ray when there is no change in the medium. So since there is because of the change in medium, here light enters from water to air. Light is entering from water medium to air medium, and hence there will be change in the direction of the light ray. So when light travels from denser to rarer medium, it will bend away from the normal. So remember that point. When light travels from denser to rarer medium, it will bend away from the normal. So this is the actual direction of the light ray. So in which way it will bend? Either towards the normal or away from the normal. So it depends on the direction of the light from which medium to which medium it was traveling. Here the light is traveling from denser medium to rarer medium. So when the light travels from denser to rarer medium, it will bend away from the normal. Away from the normal. So let us consider the another case, that is when light travels from rarer to denser medium. When light travels from rarer to denser. So consider the boundary separating the two mediums. Again here also is considering A, which is a rarer medium, and again I have considered water, and it is a denser medium. So again I have considered an incident light ray. So to know the angles, we need to draw the normal line. This is the normal line end. So this is the actual path of the light ray. This is the actual path of the light ray. So when light travels from rarer to denser medium, it will bend towards the normal. When light travels from rarer to denser medium, it will bend towards the normal. So this is the important point to remember, that when light travels from denser to rarer, it will bend away from the normal, and when light travels from rarer to denser, it will bend towards the normal. So let us see what are the angles here. So here this is the incident ray, and this one is refracted ray. So the angle made by the incident ray with normal is called as incident angle I. So the angle made by the normal line with the refracted ray is called as refracted angle R. If you observe these two angles, here refracted angle is greater than incident angle, or incident angle is less than refracted angle. Incident angle is less than refracted angle. So if you observe here, this is the incident angle I, and this is the refracted angle R. So here the angle of incidence I, if you observe carefully, you will come to know that geometrically you can observe clearly with your eyes, that is incident angle I is greater than refracted angle R. Incident angle I is greater than refracted angle R. So these are the main two different cases of refraction of light. One is when light travels from denser to rarer medium, and another one is when light travels from rarer to denser medium. So let us know that what is the reason behind this change in direction of light. So what makes the light to change its direction when it is traveling from one medium to another medium? So when light travels from one medium to another medium, some bend will occur and change its direction. So it is due to the change in the speed. This change in direction of light is occurred due to the change in speed. The speed of the light is changing. The speed of the light is changing. What is the speed of the light in air or vacuum? The speed of the light in air is denoted as c, that is equal to 3 into 10 to the power of 8 meters per second. 3 into 10 to the power of 8 meters per second. So this is the speed of the light in air. If the light changes its medium, the speed is also changing. The speed of the light is different in air when compared to its speed in water. So because of that change, the light undergoes a change in its direction. The light is changing its direction because of the change of its speed. The light speed is changing, and due to the change in speed, the refraction was occurred. The refraction is occurred due to the change in speed. So how much bend will be there? It depends upon the change of speed. If a large change has occurred in its speed, then there will be a large deviation from its direction. If there is very less change in its speed, then there will be less deviation from its original direction. From its actual direction, there will be less deviation when there is less change in speed. If a greater change in speed was observed, then a greater deviation will be occurred. Greater in a very larger way, it will deviate from its direction. It will bend in a very large direction. It will change its angle in a high value. So let us see. We can measure the deviation. The degree of deviation can be given by a physical quantity. Here the light was deviated from its path, from its actual path. The light was deviated. So the degree of deviation, how much efficiently the light will be deviated. So this can be known with the help of new physical quantity, that is refractive index. So here you are going to learn about a new physical quantity, that is refractive index. So what is refractive index? What is refractive index? So refractive index gives an idea of how much deviation will be there in the direction of the light. When light travels from one medium to another medium, it was changing its direction. So how much capable the medium can change the direction of the light? It will be given by the refractive index. If refractive index is larger, it changes its direction largely. If the refractive index is very low, it changes its direction with low value. So let us see what is refractive index. So refractive index is denoted with n, and it is defined as ratio of speed of light in vacuum by speed of light in medium. Refractive index is defined as speed of light in vacuum to the speed of light in medium. So here speed of light in vacuum is denoted with c, and v denotes speed of light in vacuum and speed of light in medium. So the speed of light in vacuum is c, and the speed of light in air is c. There is no change in the speed of light in air and in vacuum, and hence c by c is equal to 1. So the refractive index of air is 1. The refractive index of air is 1, and the refractive index of water. The refractive index of water is 4 by 3. The refractive index of water is 4 by 3. And the refractive index of glass. The refractive index of glass is 3 by 2. The refractive index of glass is 3 by 2. One important point is the refractive index of the medium is always greater than 1. The refractive index of the medium is always greater than 1. Why? Because the denominator is having low value. Always denominator will have low value when compared to its numerator. So the light is having high velocity in vacuum. The light is having high velocity in vacuum. If the medium changes, the velocity decreases. It doesn't increases. That's why the numerator is always greater than this denominator, and hence this value n is equal to c by v is always greater than 1. The refractiveness of the medium value is always greater than 1. So what is the real meaning of this refractive index? So if the refractive index is equal to 1, then in that medium the speed of the light is c. If the refractive index is equal to 2, in that particular medium the speed of the light is half of the speed of the light in vacuum. If the refractive index is 3, then speed of the light in this particular medium is 1 by 3 of the speed of the light in vacuum. If the refractive index is n, in this particular medium the speed of the light is 1 by n of the speed of the light in vacuum. So if you know the refractive index value, you can find the speed of the light in that particular medium. So this is about the concept of refractive index. What is refractive index? Refractive index is the ratio of speed of light in vacuum to the speed of light in medium. So just remember these values. The refractive index of water and glass is very important. You have to remember these two values. This 4/3 can also be written as 1.33 and 3/2 as 1.5. The refractive index of water is 1.33 and the refractive index of glass is 1.5. So let us know about another one, that is relative refractive index. Relative refractive index. So relative refractive index. So in the name itself, it is denoting the relative refractive index. It gives the relation. It gives the relation between refractive indices. Gives the relation between refractive indices. For example, I have a duster and I have a piece of chalk, and what the cost of the piece of chalk is 2 rupees and the cost of the duster is 20. The cost of a piece of chalk is 2 and the cost of duster is 20. So how can you relate these two? What is the relation between them? The relation is the duster cost is 10 times to the cost of this piece of chalk. How can you relate these? So the cost of the duster is 10 times of the cost of piece of chalk. So you have to find out the ratio between these two values. You have found the ratio between these two values and related as the cost of the duster is 10 times of the cost of piece of chalk. You are related like that. So to obtain relation between two numbers, you are finding the ratios. Here we are getting the relations between refractive indices. So if there are two mediums, and first medium refractive index is N1 and another medium refractive index is N2, then N1 by N2 denotes relative refractive index. Relative refractive index. N1 by N2 denotes relative refractive index. Or you can find N2 by N1 also. You can find these two are the ratios between the refractive indices, which gives relative refractive index, and this is denoted as N12. It is denoted as N12, and this is the refractive index of first medium with respect to second. So what do you mean by N12? Refractive index of first medium with respect to second. So this is the refractive index of first medium with respect to second, and this is the refractive index of second medium with respect to first. We are by finding the ratios between the refractive indices, this number will indicate relative refractive index. This number will indicate relative refractive index. So we know that, and this is N21 is nothing but refractive index of second medium, refractive index of second medium with respect to first medium. The refractive index of second medium with respect to first medium. So we know that N is equal to C by V. N is equal to C by V. So if it is N1, then it is C by V1. What is V1? V1 is the speed of the light in first medium, and N2 is nothing but C by V2. C by V2. Hence here C cancel. It becomes V2 by V1. So N12 can be represented as N1 by N2, or in terms of velocities V2 by V1. N21 is equal to N2 by N1. You can represent it as C by V2 by C by V1, that is equal to V1 by V2. So the relative refractive indices can also by using the velocities of light in the mediums. So this is about relative refractive index. So what is meant by relative refractive index? The ratio of refractive index of one medium to another medium is called as relative refractive index. We are relating the refractive indices of two mediums. So this is about the concept of relative refractive index. So let us see what are the laws of refraction. What is the rules that the light will follow during refraction? What are the rules that light will follow during refraction? Those are called as laws of refraction. Pass it. So let us see about laws of refraction. So these are the rules that the light will follow during refraction. What are the rules that light will follow? So the first one is the incident ray, refracted ray, and normal line. Refracted ray and normal line lies on the same plane. These three lines lies on a same plane. Here, so this is the boundary that they are separating the two mediums. Let us consider it as air and another as water. So, if you are incident the light on it, so this is the normal line, actual path of the light ray. It will bend towards the normal when it travels from rarer to denser medium. The light is traveling from rarer to denser medium. It bends towards the normal. Here, the incident ray and refracted ray and normal line. These three lines lies on the same plane. For example, here the line is on the plane board. The incident line is situated on the plane board, and the normal line also situated on the same plane. Whereas the refracted ray also lies on the same plane. So in this way, the incident ray, normal line, and refracted ray lies on the same plane. So this is the angle of incidence. The angle made by the incident ray with normal, and the angle made by the refracted ray with the normal as refracted ray. So the relation between incident angle and refracted angle is given by Snell's law, that is sin r is equal to n2 by n1, or it is a constant value. N2 by n1. These two are numbers, so you will get a constant value. So the another rule, the another law that light will follow during refraction is Snell's law. What is Snell's law? It will use the relation between angle of incidence I and angle of refraction R. So what is the relation? Sin I by sin R is equal to n2 by n1. The relation is sin I by sin R is equal to n2 by n1. Whereas n1 is the medium that contains the incident light, and n2 is the second medium which consists of refracted ray. Here n1 is the air medium and n2 is the refractive index of the water medium. So the Snell's law is sin I by sin R is equal to n2 by n1. So these are the two laws that light will follow during refraction. So let us discuss an activity that verifying the Snell's law. Let us discuss an experimental activity that which verifies the Snell's law. So in order to verify Snell's law, let us discuss an activity, an experimental procedure to verify the Snell's law. So to verify the Snell's law, just consider a white chart. And draw two perpendicular lines. Consider the white chart and draw two perpendicular lines and name it as M prime and N prime. So the intersection point the intersection point of the two lines as O. Denote it as O. And using compass, draw a circle. Draw a circle with some radius. Draw a large circle with some radius. And by using the protractor, you can make the lines for every 10 degrees of angle. Draw these lines for every 10 degrees angle. So this is making an angle 10, and the second line is making an angle 20, and the third line is making an angle 30, and the fourth line is making an angle 40. In such a way, draw an experimental arrangement like this. So after drawing the lines using the protractor, by dividing this total circle with 10 degrees of angle of lines, then denote the angles from this vertical line. Denote the angles from this vertical line. This is 0. Then the next line to the vertical is 10, and the next one is 20, and the next one has 30, and so on up to 90. And again denote the angles as from the vertical line. This vertical line is 0, indicates 0, and this has 10, and next one is 20. So in this way, denote the numerical values in this way: 0, 10, 20, 30. And again from the vertical section, like this: 0, 10, 20, 30, and so on. And again from the vertical section, denote it as 10, 20, and so on up to 90. So why we are denoting it from the vertical line? Why? Because we will measure the refraction angle or incident angle from the normal line. We will measure the refracted angles or incident angles with the normal lines, and hence just denote these angles with normal line. This is the normal line. Now consider a semicircular glass. A semicircular glass slab. You need to use a semicircular glass. Consider a semicircular glass and place this semicircular glass such that its diameter is along the horizontal line that you have drawn. You have to place this. This is a glass material which is in the shape of a semicircle. This is a glass material which is in the shape of semicircle, and place it on the white chart. And you are already prepared some experimental arrangement, and place the semicircular glass on the white chart such that its diameter is along the line M line. Place the semicircular glass in such a way. So now consider a laser light source. You consider a laser light source and incident. Now consider a laser light source and incident the light ray at some particular angle. So I have incident a light ray. So I have incident the light ray at an angle of 20 degrees, and the light ray will passes through this semicircular glass and emerges out. Here light is entering from air medium to glass medium. Denser to denser medium. It depends towards the normal. So after placing the semicircular glass, consider a laser light source and incident the light at certain angle. So here I have incident the light at an angle of 20 degrees, and the emergent light ray will be observed at some other angle. So measure those angles. So initially you have to prepare a table. It will consist serial number and another one as incident angle you will measure. You will change the incident angles, and by observing the refracted ray you can also know the angle of refractions, that is R, and from these two values find out sin I, sin R, and sin I by sin R is another column, sin I by sin R. Prepare a table like this. So this is an experimental procedure you need to do to verify the Snell's law. So in this experiment, you have to prepare an arrangement like this on a white chart, and you must have a semicircular glass and a laser light source. So incident a laser light and semicircular glass at some certain angle. So here I have started the experiment by taking the incident angle as 20. you will observe from the experiment, you will observe the refracted angle also and note it down. Here. And then from these two values, find out sin I and sin R. And again, find the ratio between sin I and sin R. So this is the value initially we will take, and these values will obtain. This value, R value will obtain from the experimental procedure, and we can calculate sin I and sin R by using scientific calculator. So again, repeat the experiment by changing the angle of incidence to 30, and again repeat the experiment by making the angle of incidence as 40, and again 50. So repeat the experiment with different angle of incidences, and you will know the corresponding values of R from the experiment, and you can find these sin I and sin R values by using the calculator. If you calculate this ratio sin I by sin R, if you observe the column, the values in this column, this column contains a constant value. So what is the conclusion from this experiment is, you will observe some constant values in this column. So what is this column? Sin I by sin R is equal to constant. From this experiment, you will know that sin I by sin R is equal to constant. So which is nothing but Snell's law. And here the constant is equal to n2 by n1. What is n2? The second medium. The light enters from first medium air to last medium semicircular glass. So this is the second medium is glass and the first medium is air. So this constant will be equal to n2 by n1. So this is nothing but Snell's law. So this is the experimental procedure to verify the Snell's law. So this is about verification and experiment for the verification of Snell's law. So in the next class we will learn about total internal reflection of the light, which is a new phenomenon of light.